Hello, I'm Nazanin Shojai Seifabad, and this is Unit 5. So today we are going to talk about how the samples we were given, which are fluorine, krypton, silver, and barium, bond with other elements and why they exist as solid or gas at room temperature, and how this affects the way they should be stored. And the main aim of this presentation is to explain different types of bonding, show how bonding and structure influence physical properties, and describe molecular shapes using electron pair repulsion theory, and finally explain the role of intermolecular forces. So these are our samples, uh, which are four, and fluorine is a nonmetal and exists as diatomic molecule. Krypton is a noble gas here, made up of individual atoms, and as you know, noble gases are inert. Silver is a transition metal, and barium is an alkaline metal, which also called alkaline earth metal. So together, these samples allow us to explore a wide range of bonding types, including covalent, metallic bond, ionic, and coordinate bonding. So, metals such as silver are held together by metallic bonding, where electrons are delocalized. So we've got delocalized electron here, and also they are called free electron, free to move throughout the structure. This explains why metals conduct electricity. So due to their free and delocalized electron, they are good conduct of electricity, and also they can be shaped easily. So barium and fluorine, they form ionic compound, which are called barium fluoride, where electrons are transferred from a metal to a non-metal here, and they make ions instead of atoms. So fluorine molecule are covalently bonded with electrons shared between atoms. So at the end, we've got silver can also form coordinate bonds. For example, in the complex of here, where both electrons in the bond come from the nitrogen atom in ammonia. So these are four types of bonds. So here, electronegativity helps us to predict the type of bond that will form. When the difference in electronegativity is very small, such as here, the bond between 2F, the bond is purely covalent. The large difference, like the second one, which are metal and non-metal, which can shape the ionic bond. So intermediate differences lead to polar covalent bonds. And in coordinate bonding, such as between silver and ammonia, so one atom provides both bonding electrons, even though the bond behaves like a normal covalent bond. So here we can talk about their structure and properties and how we can use them. So the physical properties of substances depend strongly on their bonding and structure. I mean, metallic silver has a high melting point and conducts electricity very well, which makes it useful for electronics or electronic products. So barium fluoride is an ionic solid, so it is hard and brittle and has a high melting point, so which help us to use it in some industries and medical imaging. Small covalent molecules like fluorine here and monoatomic gases like krypton have low melting point and low boiling point. That's why we can use it um, in different things that we need to be reactive. So, and they are gases at room temperature. And giant covalent structure, which is the most common one, is diamond. So are extremely strong, and also they have very high melting point and boiling point. So, and which is really sharp, and they can use it as cutting tools. So the shape of molecules and ions can be predicted by using electron pair repulsion theory. So carbon dioxide has a linear shape, water is bent, ammonia is triangle, and pyramidal, and also methane is tetrahedral. When the number of electron pairs changes, the shape of the the shape of them will change. So, for example, ammonia is a triangle pyramidal, but ammonium ion has a tetrahedral shape. So here, sulfur, as we've got, sulfur trioxide is a trigonal planar, while the sulfate ion is tetrahedral. So, intermolecular forces act between molecules and atoms and they can affect physical properties. So, permanent dipole forces occur between polar molecules such as hydrogen and hydrogen chloride. All participles experience London dispersion forces, which are especially important in substances like fluorine and krypton. Hydrogen bonding is the strongest type here, is the strongest type of intermolecular forces, and explain why substances like water have unusually high boiling points. So, bonding and intermolecular forces explain why a substance exists in different states at room temperature. For example, fluorine has weak intermolecular forces, so it is a gas and must be stored under controlled and pressurized conditions. Krypton is an inert, which is an inert noble gas, and it is stored in a sealed cylinders. Silver is a solid metal and should be kept dry to prevent tarnishing. And barium compounds are ionic solids and must be stored carefully because of their reactivity and being toxic. So, the electron configuration of these elements help to explain their behavior and their structure. So, fluorine has the configuration of 1s2, 2s2, 2p5, and giants 1 electron to form fluorine ion, which is called fluoride. Krypton already has a full outer shell as it is a noble gas. And so krypton has got 8 electrons in their outer shell. That's why it is extra stability. So that's why it explains why it's chemically unreactive. Silver loses 1 outer electron to form iron positive, while barium loses 2 electrons to form barium negative. Actually, barium 2 positive. So these electron arrangements directly influence the types of bonds each element can form. And these are the references here. All the information and diagrams which are used in this presentation are supported by reliable sources and scientific sources. Thank you so much.